Hi everyone, welcome to day 8 of Just Enough Python for AI. Yesterday we saw some basic operations using NumPy over arrays. Today we will look at more mathematical operations using NumPy, and most importantly we will look at useful matrix operations. So let's get started. So by now we already know NumPy as a Python library that helps us with mathematical operations, especially with arrays. Now let's look at some more examples. So let's first import NumPy as NP, and then we are creating two one-dimensional arrays. A is 1, 2 and 3, and then B is 4, 5 and 6. And then we are doing element-wise operations. We are saying A plus B for addition, A minus B for subtraction, A into B for multiplication, A divided by B for division, and then we are saying A to the power 2. This is for exponential operation. We saw this example in the last class as well. Now let's first execute this code and see how this piece of code behaves. This is our array A and B. So when we say A plus B, what we get is an element-wise addition. So 1 gets added to 4, this 2 gets added to 5, this 3 gets added to 6. So we get 5, then 7, and then 9. This is the beauty of NumPy. To do this with lists, you'll have to write a for loop to loop through each one of these elements in each of these lists, if it's a list, and then add them individually. With NumPy, it is as easy as A plus B. The same with A minus B, we are subtracting 4, because 4 is B, from 1. So 1 minus 4, 2 minus 5, which is minus 3. 1 minus 4 is also minus 3. And then 3 minus 6 is also minus 3. And that's what you are receiving here. We are subtracting element-wise. Same with multiplication, A into B. It's 1 into 4, which is 4. 2 into 5 is 10. And then 3 into 6 is 18. That's what you get here. Division, very easy. Similar concept. A by 4 is 0.25. 2 by 5 is 0.4. And 3 by 6 is 0.5. Exponential, we are squaring each element of array A. So 1 to the power 2 is 1, 2 to the power 2 is 4, and then 3 to the power 2 is 9. Element-wise mathematical operations on arrays. This is what we did with one-dimensional array. Let's see what we can do with two-dimensional array. Let's first execute this code and then we will look at the outputs. We are first creating a two-dimensional array named matrix underscore 1 and matrix underscore 2. If you are wondering, a two-dimensional array can also be called matrix. You will hear this word matrix a lot. When you hear matrix, understand that we're talking about a two-dimensional or a three-dimensional array. So matrix underscore 1 is equal to np.array. We have two rows. The first row is 1, 2 and the second row is 3, 4. It's the same with matrix underscore 2. The first row is 5, 6 and the second row is 7, 8. And then we are saying matrix 1 plus matrix 2. It will again do element-wise addition. So 1 will get added to 5. 2 will get added to 6. 3 will get added to 7, while 4 will get added to 8. And you get 6, 8, 10, 12. The next is element-wise multiplication, matrix 1 into matrix 2. We will again do multiplication element-wise. 1 into 5 is 5. 2 into 6 is 12, which is here. And 3 into 7 is 21. And 4 into 8 is 32. And next we are adding 10 to each element of matrix 1. So this becomes 11, this becomes 12, this becomes 13, and this becomes 14. And that's what you get here. Next, we will look at aggregate functions. NumPy has built-in functions that summarizes data such as finding sums, averages, and extremes. And these aggregate functions can either operate on the entire array or along specific axes. That means either along the rows or along the columns in a 2D array. Let's look at the example and then understand. So, we are first creating a one-dimensional array with values 1, 4, 5, 3, 6, and 5. And then we are saying np.sum. .sum is a built-in function of NumPy, and we are passing the array within the brackets. So what it will do a sum of all the elements in this array. So if you add these, 1 plus 4, 5, 5 plus 5, 10, 10 plus 3 is 13, 13 plus 6 is 19, and 19 plus 5 is 24, which is what we are getting here. Next, we are finding the mean of this array. So mean of all the elements of this array. And mean is nothing but average. So we'll first add these together and then we'll divide by the number of elements. We already know the sum is 24, and the number of elements is 1, 2, 3, 4, 5, 6. So 6. So 24 by 6 is 4. The mean is 4, and that's what we are receiving here. Next, we are looking at standard deviation. We use np.std and then we pass the array within brackets. Now, standard deviation is a statistical concept that I will not cover right now. It's a concept for a different class, a different topic. But just understand that we have a way to calculate standard deviation of an array using a built-in function. We don't have to write extra lines of codes. Next, we are finding the minimum value of all the elements in this array, which is 1 right here. 1 is the minimum. Then we are finding the maximum value using .max function. For min, we use .min function. For max, we will see that I think 6 is the maximum value, and that's what we are getting here. And then we have another function named .prod, which basically multiplies each element. So you get 1 into 4 into 5 into 3 into 6 into 5, which comes to 1800. It's a product of all the elements in that array. So all these examples were using a one-dimensional array. What if we have a two-dimensional array? Let's see. We are first creating a two-dimensional array named matrix. The first row is 1, 2, and 3, and the second row is 4, 5, and 6. It has 2 rows and 3 columns. Next, we want to print the sum of each columns. The built-in function is still the same, np.sum. We are using .sum here, and we are passing the matrix, the array, which is here. But there is an additional parameter that we are passing. We are saying axis is equal to 0. When we say axis is equal to 0, it's going to give you the sum of each column. The moment we make axis is equal to 1, it's going to give you the sum of each row. And then we are also calculating the mean of each row. Axis 1 is always row-wise, while axis 0 is column-wise. Let's execute this code and see the answers. So, sum of each column. So we have 1 plus 4, which is 5, 2 plus 5 is 7, and then 3 plus 6 is 9. So we are doing sum for each column. If you see, we are adding vertically. For second one, we are adding horizontally. We are calculating sum of each row. So we'll have 1 plus 2 plus 3, which is 6. And then 4 plus 5 is 9, and 9 plus 6 is 15. So you get 6 and 15. Then we say mean of each row. So the mean of this is 2, and the mean of this is 5. And if you don't specify these axes, what will happen is that it's gonna calculate this sum or this mean on the entire array. So this is how you apply aggregate functions along rows or columns. For rows, axis is equal to 1, and for columns, axis is equal to 0. Next comes the matrix operations in NumPy. Now, matrix operations is by far the most important concept in NumPy. It's also the most confusing concept in NumPy, and also often the most difficult concept in NumPy. And to give you an idea of how important matrix multiplication is, I would like you to know that most of the maths behind most of the AI models, most of the deep learning models, most of the large language models is nothing but matrix multiplication. It's that important. Let's look at some of the examples. Let's execute this code first and see the output. We are first creating a one-dimensional array with 1, 2, and 3 as elements, and then we are creating another one-dimensional array named B with 4, 5, and 6 as elements. We use np dot. So dot is the built-in function for matrix multiplication or dot product. When it's one-dimensional array, when the arrays involved are one-dimensional, we often call it dot product. When the arrays involved are two-dimensional, we call it matrix multiplication, but they are essentially the same. So np dot a comma b will give you dot product of matrix A and matrix B, which is 1 into 4 plus 2 into 5 plus 3 into 6, which is what we got here, dot product of vectors. One-dimensional arrays are also called vectors, by the way. Next, we are defining two matrices, two two-dimensional arrays, matrix 1 and matrix 2, with the first matrix having 2 rows and 2 columns, 1, 2, 3, and 4 being the elements, and the second matrix, second two-dimensional array, having elements 5, 6, 7, and 8, 2 rows and 2 columns in each. When we apply np dot and then we assign matrix 1 and matrix 2 here, we will get a dot product of these two matrices or matrix multiplications of these two matrices. And by the way, instead of this np dot function, we could have also used this matrix multiplication operator, which is nothing but at. So we could have said matrix underscore 1 at matrix underscore 2, and it would have done the same thing. Now let's understand what's happening in this matrix multiplication. We have the output, but I'm not printing this matrix 1 and matrix 2. Let's print that as well to visualize it more easily. Let's say just print matrix 1 and then print matrix 2, and then okay. So now our matrix 1 is 1, 2, 3, 4, and matrix 2 is 5, 6, 7, 8. And we are saying we want to do a matrix multiplication, matrix 1 with matrix 2. So this is our final output. We have 19, 22, 43, and 50. Our matrix is of size 2, 2 rows and 2 columns. Now let's see how we arrive at these values. So to get 90, that is the element at row 1 and column 1, we will operate on row 1 of matrix 1 and column 1 of matrix 2. Row 1 of matrix 1 is 1, 2, and column 1 of matrix 2 is 5 and 7. We will do 1 into 5 plus 2 into 7, which is 1 into 5 is 5 plus 2 into 7 is 14. So 14 plus 5 is 19. Next, to get this 22, we will operate on row 1 of matrix 1 and then column 2 of matrix 2. The column 2 is 6 and 8. So we will do 1 into 6 plus 2 into 8, which is 1 into 6 is 6 and 2 into 8 is 16. 16 plus 6 is 22. Now, next one. 43. How do we get 43? For this, we will use the row 2 of matrix 1, and column 1 of matrix 2. So row 2 is 3 into 5, 15. 3 into 5 is 15. And then 4 into 7 is 28. 28 plus 15 is 43. That's what we get here. And to get this value, we operate on row 2 of matrix 1 and then column 2 of matrix 2. So 3 into 6 is 18 and 4 into 8 is 32. So 32 and 18, 32 plus 18 is 50. That's what we are receiving here. This is matrix multiplication. I have sourced this diagram, this picture from internet. This explains how we calculate the matrix multiplication using the same example. 1, 2, 3, 4 and 5, 6, 7, 8. The only thing that I don't like in this picture is that I would have preferred this 19 value first and 22 value being second, because that's how they are in this final matrix. But here the order is switched. But you can understand what we are doing here. The same thing that I explained here, how we are arriving at these values, it is explained here. We get 22 by 1 into 6 plus 2 into 8. 22 here. We get 19 by 1 into 5 and then 2 into 7 plus 2 into 7. And similarly 43 and 50. Have a look at this example and you will find more such examples on internet. If you just search matrix multiplication and if you go to the images tab, you will see more such examples. If it's not clear to you with this example, have a look at more examples. One thing to notice is that you can have matrices of different sizes. Even though I used a matrix, two matrices of same sizes for easier explanation. Both of them were of size 2, 2 rows and 2 columns. Both matrix A and matrix B are of size 2, 2. You can have a matrix multiplication between two matrices where the size is not same. But the key factor is that the number of columns in matrix A should be equal to number of rows in matrix B. That is, the number of columns in your first matrix should be equal to the number of rows in your second matrix. As long as this restriction is followed, you will be able to do matrix multiplication. And very often in the AI field, we do matrix multiplication between two matrices of different sizes. Now let's look at transpose. So the easiest way to understand transpose is that you are transforming your existing matrix in such a way that the rows, the elements in rows becomes your columns and your columns becomes your rows. Let's look at one example, and by the way, we use .t to achieve transpose. So if you look at the original matrix, it has 3 rows and 2 columns. Our first row was 1 and 2, second row was 3 and 4, and then the third row was 5 and 6. After transpose, our columns, which is 1, 3 and 5, becomes our first rows, and then the second column, 2, 4 and 6, becomes our second row. This is transpose. Now let's look at the concept of identity matrices and inverses. So what is a identity matrix? The identity matrix acts as the equivalent of 1 for matrix multiplication. Now if you compare it with normal multiplication, when you multiply any element with 1, what you receive? You receive the same element. So if you are applying, say, 10 into 1, you receive 10. If you are applying 5 into 1, you get 5. Same way, if you multiply a matrix with identity matrix, you get the same matrix. What's the use? We will see. Even though it looks like of no use, it does have use. Let's first execute this code. So here we are first specifying the name of the matrix, which is identity. We are calling it identity. We can call it anything else as well. equal to np.i. .i is the built-in function from NumPy to create identity matrix, and then we are passing the size. We are saying 3, so it will create a 3 by 3 matrix, that is 3 rows and 3 columns. And this is how it looks like. You see that the diagonal elements are 1, only one diagonal, not the other diagonal. These diagonal elements are 1 while all the other elements are 0. When you multiply this matrix with any other matrix, you get the same matrix. Next, we have matrix inverse. So we can also calculate the inverse of a matrix. What's the inverse of a matrix? Let's first execute this code and then understand. So we have our initial matrix, that is 2 rows and 2 columns, 1, 2, 3, 4. And then we are calculating the inverse of this matrix. We are naming it inverse using a built-in function np.linearalgebra.inverse inv, and then we are passing this matrix name inside. And this is what we get. So our inverse matrix is -2, 1, 1.5 and minus 0.5. Now what is the importance of a matrix inverse? So if you multiply the original matrix with its own inverse, you actually get a identity matrix, which is what we got here. So if you multiply this matrix, which is 1, 2, 3, 4, with this matrix inverse, you should get a identity matrix. This is how, in fact, you can verify if a particular matrix is an inverse or not. So here we are doing a dot product, which is a matrix multiplication of this original matrix and then the inverse of it, and this is what we receive. Now you might feel that this is not an identity matrix, but I would like you to have a closer look. Identity matrix has 1 in the diagonal and then zeros everywhere else. Here our identity matrix is of size 2 and 2, 2 rows and 2 columns. Our diagonals are 1, right? This is 0. This you might feel is not 0, but look closely. This is very, 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 very close to 0. So what we have here is 8.8817842 10 to the power minus 16. So essentially it means you have 0 point and then 15 zeros. Yeah, 15 zeros and then you have 8. So it's like 0.00000 15 times, and then eventually you have 8.88 something. This is very, 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 very close to 0, and for all practical purposes, this is also equal to 0, and hence this is a identity matrix. This brings us to the end of today's topic, and it also brings us to the section called quick exercises. Only 3 questions for today, nothing very difficult. I'm pretty sure everybody will be able to get through it. If not, you know where to find help, the comment box. I will try my best to respond to each one of you. With that, we reach the section where we solve the previous video's questions. So day 7, exercise solutions. Now the first question was, create the following array using NumPy, a 1-dimensional array with values from 10 to 50, a 2-dimensional array of zeros with shape 4, 3, that is 4 rows and 3 columns, and then a random 2 by 2 matrix, which is 2 rows and 2 columns. And this is our sample solution. We are going to execute the code and see if the answer matches our question or not. A 1-dimensional array with values 10 to 50. Our 1D array is here and the values are from 10 to 50. While solving, you can notice that I gave the end of the range to 51 so that we can have 50 because the end is never included. Now the next was 2-dimensional array of size 4, 3 of zeros. So we are using the dot zeros function of NumPy, and we specify the rows as 4 and the number of columns as 3, and this is what we get: a array of zeros with 4 rows and 3 columns. And the next one was a random matrix with 2 by 2 as size. So we are using np.random.ran, and we are specifying the size here 2 by 2, and then this is what we get: a random 2 by 2 matrix. The next question was to perform the following operations: add 5 to every element of an array, and then select all elements greater than 25 in an array. So I'm using the same array that I defined here, array 1D, which is an array of elements from 10 to 50. And now we are saying that we are going to add 5 to every element. So we should get an array which has elements from 15 to 55 for this. And then we will select all the elements which are greater than 25. Let's execute this code. So here we get an array with values with elements from 15 to 55. And then with this, we get all the elements which are greater than 25. So we get from 26 to 50 on the original array, which is array underscore 1D. The next question was to reshape a one-dimensional array of size 12 into a 3 by 4 matrix. And this is the solution here. Now I'm doing it in one step. You can do it in multiple steps, in 2 steps as well. So I'm first creating an array with np.arange from 0 to 12, with 12 not included. And then I'm reshaping it to 3 rows and 4 columns. And that's what we are getting here: 0, 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, 11. Our next question was to slice a 2-dimensional array to extract the first row and all rows but only the second column. So basically the second column. So first we are creating a 2-dimensional array. It could be anything for you. For me, this is the array that I'm creating. And then I'm extracting the first row here of this array underscore 2D. I'm passing index 0. This index 0 is for the row. Next, we are extracting all the rows but only the second column, which is nothing but second column. So we will extract 2, 5, and 8. And this is what we are doing here. We are specifying this array. We are saying here all the rows and then column number 1, that is second column. So we get first row for this first part, that is 1, 2, and 3, and second column for the second part, 2, 5, 8. This brings us to the end of today's video, and we finally concluded NumPy. In the next video, we will look at pandas. Now, pandas is extremely important. It is the bread and butter of every data scientist or AI professional. You have to know pandas. You have to master pandas. See you in the next one.